Hi, I was asked to do this problem. This is 13-7, number 8. So it's linear regression, line of best fit. And I understand this is a little tedious, a little bit of work. So I'm with you on that. It can be a little overwhelming, a lot of numbers to work with. I have posted videos, not made by me, but by others on YouTube, doing this in Excel. So anyway, we're going to find the line of best fit with a couple things we have to find here. Y equals mx plus b. So these are the numbers we're going to try to get. I think we're going to get there. So m is going to be n, the number of data points, times the sum of x, y, minus the sum of x times the sum of y, over n times the sum of x squared minus the sum of x quantity squared. And then our b would be the sum of y minus m from here times the sum of x over n, our number of data points. So let's go ahead and list our data points. We have 100, 90, 60, 50, 40, and 30. That's 1, 2, 3, 4, 5, 6 data points. So n in this case will be 6. And then let me just recopy the y. And we have 1, 5, 6, 9, 10, and 13. Okay. Now we have to have a sum, or a column of x squareds. So that's going to be 10,000, then 8,100, 3,600, 2,500, 1,600, and 900. Now that's going to be for down there. And then we need a column of x times y. So 1 times 100 is 100. 90 times 5 is going to be 450. 60 times 6 is 360. 50 times 9 is 450. 40 times 10 is 400. And 30 times 13 is 390. Now I'm looking at the data here, and it makes me wonder, as x gets smaller, y is getting bigger, so I feel like we should have a negative here, but let's see what happens. Okay. Oops. Now we need to have the sum of everything. So let's get out the handy dandy calculator and start adding things up. So we're going to have 100 plus 90 plus 60 plus 50 plus 40 plus 30. And that's 370. And then 1 plus 5 plus 6 plus 9 plus 10 plus 13. That's 44. Then 10,000 plus 8,100 plus 3,600 plus 2,500 plus 1,600 plus 900. And that's 26,700. 100 plus 450 plus 360 plus 450 again plus 400 plus 390. It's 2,150. Okay. So our m is going to be n. N is the number of data point pairs, and we have 6 pairs. So 6 times the sum of x, y, that's going to be 2,150. Minus the sum of the x's, which is 370, times the sum of the y's, which is 44, divided by 6 times the sum of the x squares. Okay, here's our sum of the x squares, 26,700, minus the sum of x's, which is 370, squared. So m is going to be 12,900 minus 16,280 over 160,200 minus 136,900. Okay. So 12,900 minus 16,280 is negative 3,380. 6,200 minus 136,900 to 23,300, and that works out to be negative 0.145064. Okay, and let's see what b is going to be. B equals, as I had above, the sum of the y and sum of y's, so that's going to be 44, minus m times the sum of the x's. So our m was negative 0.145064, and the sum of the x's was 370, all over n. That was a 6. So b equals 44 minus a negative 0.145064 times 370 divided by 6. And I get from that calculation 16.2789. Okay, I just checked the computer, and that is the correct answer. So that it's y equals negative 0.14. That said around to the nearest hundredth. So negative 0.15 x plus 16.28. That would be the line of best fit for this data. Okay, I hope that makes sense.